Okay, so for this function, this is the cosine function. The cosine function, what we're doing is looking at the domain and range of the cosine function. Then we will examine the sine function. The cosine function has the domain from negative infinity to positive infinity. It goes on forever and ever in both directions. The range, though, remember folks, in a sinusoidal function, whether it be sine or cosine, it goes from negative 1 up to 1. Now we're including it. So including square bracket, negative 1, up to 1, square bracket again. Now, increasing. This function increases and decreases in a regular pattern. So we must determine what that pattern is. Alright, so looking at the last little bit, increasing intervals. Now remember that in this cosine function, if we look here, it increases from this point down here, which be when it reaches negative 1, which is at 180 degrees, and reaches the top part at 360. So we know for a fact that the interval increases starting at 180 degrees, and it will end at 360 before it shoots back down again. Now, this repeats itself every single 360 degrees. By repeating itself every 360 degrees, we have to say, okay, so we can take the 180, add 360, and it will begin to increase again. Now, which direction do we add it in? Well, n, this little n, 360n, right here that you see here, means that n belonging to the world of integers. So that means whether I go left or right, in 360-degree intervals, I will have a repeat of the following increasing intervals. All right, see your teacher if you need more explanation. Now, decreasing goes from 0 to 360. Oops, that's too much information, folks. So 0 to 360 means 0 to 180, sorry. But again, it repeats every 360 degrees because of its repetitive pattern. So from 0 to 180, it increases. So if we look at the graph, decreases. 0 to 180, the function is decreasing in 360-degree intervals. And so every 360 degrees, it's going to again begin to decrease, whether we move from left or right. There are no discontinuities or asymptotes. The x-intercepts are at 90 degrees, and the next one you'd see is at 270. If you try and figure out the next one after that, you'll notice quickly that it will be 450 degrees. So, if I look at the pattern of numbers, I say, all right, 90 degrees, 270 degrees, 450 degrees, you'll see that there's a pattern in these numbers. And if you remember sequences from grade 11, you remember that this has a pattern. This pattern means that every 90 degrees plus 180 degrees, n, means that there will be a x-intercept, or a 0. So 90 plus 180n will result in another x-intercept. Whether they be going forwards or backwards, we will have an x-intercept every 180 degrees, again, where n belongs to the world of integers. Y-intercept, lucky for us, only one, folks. The y-intercept is going to be at 0, 1. So again, the x-intercept is 90 plus 180, every n steps, n belonging to world of integers. Now remember, an integer symbol is a z. So if we write a z, it will have a double bar z in the middle to represent integers. So that double bar, we make it a little bit thicker. All right, y-intercept, lucky for us, is going to be at 0, 1, only one value. Symmetry. A cosine function is even, folks. It has an even symmetry because I reflect it horizontally, I'll end up with the same function. Finally, end behavior. As x approaches, whether it's positive or negative infinity, the y value oscillates between plus or minus 1. Because as x approaches positive or negative infinity, it continues to oscillate between positive and negative 1.